And we are now live. So welcome to our first .NET Community Stand-Up, where we focus on languages and runtimes. Might have followed the ASP.NET Community Stand-Up. It's going on for at least, I think, a year, if not longer even. And so we very recently expanded this to the rest of .NET. So last week, James started the first show where we talked about the mobile stuff, and today we're focusing on language and runtime stuff. And so I have a bunch of friends here from all over the place. So let's start with you, John.
I'm John Sakura. I'm on the developer experience team. I work on try.net. And yeah.
Cool. So my name is Immo Landworth. I'm a program manager on the .NET platform team. So I focus on the base class library, the .NET standard, like all the things related to library development.
I'm Matt Jorgensen. I'm a language designer. I work primarily on the design of C#.
I'm Philip Carter. I work on the F# language and tools and .NET project integration tooling.
And I'm Kathleen Dollard. I work on the CLI and SDK for .NET Core. I also work on MSBuild and languages, including being the Visual Basic PM.
And last but definitely not least, my name is Rich Lander. I work on the .NET Runtime and kind of just really all aspects of .NET Core that I get my hands on.
Awesome. So since we are live, I encourage everybody who is following on YouTube and Twitch to ask questions. And so God will, and I'm not screwing this up, I will try to follow what questions there are, and we make sure we will answer them as we go along for the ride. As I said, you can follow us on both YouTube and Twitch. I don't know where you are right now, but we will support both platforms, and you should feel free to comment in either one of them, and so it should just work fine, ideally. In the perfect one. Some mic problems here. So anyway, so the question is, Rich, do you want to start with what's new in the .NET Runtime?
Well, actually, first I thought it would make sense to talk about the .NET Core 3.0 release. Oh, yeah, and just give an update on that. So that's the main thing I think most of us in this room are working on. So .NET Core 3.0 is kind of obviously the logical successor to .NET Core 2.1 and 2.2, both of which have already shipped. And this is the one where we're adding WPF and Windows Forms. And so we released first preview on December 4th, I believe, of last year. And there are going to be more previews. We're hoping to get another preview out this month in January. It's possible it'll slip into early February. And then we're kind of planning on more or less a preview every month or month and a half after that. So it's going pretty well, although there's still quite a lot of work left to do. And some of what we're going to be talking about, I think, on this call and subsequent calls are features that I think maybe deserve a little more attention, or where we have some specific design questions that could use some more community feedback. So I don't know if anyone, before we move on to any other topic, if anyone wants to add anything in this room on the release itself.
I think the biggest one you said is WinForms and WPF. The one thing that I would like to reiterate is because when we shipped .NET Core v1, there was this very big push from us to say this is a cross-platform runtime, right? And so with WPF and WinForms, the number one question I think I've gotten was, so does it mean we make WPF and WinForms cross-platform? And the answer is no. They have both Windows in the name, and we intend to also support Windows only as moving forward, hopefully also Mac only and Linux only technologies on top of .NET Core, right? But the platform itself will remain cross-platform, and but that doesn't mean that we cannot have operating system specific extensions on top of it to make it easier for people to write applications that feel really native on whatever particular platform they are on, right? And that's the same thing we do for iOS and Android, where we provide you with the ability to write native applications for those as well. So that seems to be something worth pointing out. And then Rich, the other thing that might be worth pointing out, because you're involved with this as well, is everything we do in the IoT and GPIO and Raspberry Pi thing, which I think most people are also not really aware of what's going on there. Do you want to give us a brief overview of that?
Sure. So in the past, we were trying to make .NET work, .NET Framework and .NET Core work super well on really big machines. So if you had this business that was doing super well, and all of a sudden you start with 1,000 users, then you end up with 1 million users, and then like 10 billion users, your .NET site could kind of scale along with your business, and I think we did well with that. Now we actually see devices coming out that are extremely small. So Raspberry Pi is a good example of that. It's like 1 gigahertz and like half a gig of RAM. Actually, that part I can't quite remember. So we need to make .NET work well in those devices. This is for like industrial applications. We're actually talking with car companies. Volkswagen is an example. And where we're trying to make our products work better for them in these small use cases. And the other thing is like these Raspberry Pis, if you look at them, they have all these little pins on them, and you can actually program them. And so now we have libraries. If I had thought about this, I'd actually have a Raspberry Pi right here. But you can actually program those pins to like read data from sensors and like make lights blink and put scrolling text across LED panels. Those are the sorts of things we're working on, and we expect a whole new class of applications to be written with .NET on devices like that. So we shipped a preview at the same time as .NET Core Preview 1. We actually didn't ship the library on NuGet.org. It was only on MyGet still at that point and at this point. And we intend to ship the library on NuGet.org with Preview 2. We were still like refactoring the library quite a bit. There's now the repository is now open. It's at .NET/IoT, and we have samples there. And the idea is that the community, it's easy for them to adopt IoT and can work alongside with us.
That sounds great. Anything else for the release, Kathleen?
Oh, I was just gonna ask Rich to talk a little bit about the targeting and other changes that we're doing to RIDs and to framework and the defaults and roll forward and all sorts of stuff is going on in that world. And
okay, so, I feel like I'm doing a lot of talking at the start. So a couple points on that. There have been some design issues that we've been discussing. The first one is we've been spending a lot of time talking about targeting C#8 recently. So as you could imagine, a bunch of us dog food the product. We're installing these previews on our machine every day and trying to use them. And a few of us observed that there's this inconsistency in the product, among many, but this key inconsistency, which is when you start running a .NET Core 3.0 project, you get preview runtime, preview CLI, and all that kind of makes sense. But you're still using C# 7. Is it 7.0 or 7.2? I'm actually not, or 7.3. I'm not sure. But definitely not C# 8 by default, and that personally makes no sense to me. People, when they opt into installing .NET Core 3 builds, they should get preview everything, and it should be super easy to try all the new features. That was not the case, and we're talking about how to make it so that C# language versions fit into that. So that's one thing. So that's our direction, is when you install previews that you should get preview everything, including languages. So I'd love to get feedback on that. The other one is we've kind of had this story with roll forward, both with .NET Framework and .NET Core. Just talking about .NET Core, at the very start, we only rolled forward on patch versions. So this is, we have these 3-part version numbers with .NET Core. It's like, 1.0.6 or, 2.1.1, and we would only roll forward on the very last version number. And then when we shipped .NET Core 2.1, we decided, we really do need to roll forward on this minor version because, the minor versions are quite compatible. There'll be plenty of cases where people have a .NET Core 2 app and 2.0 app and try and run it on .NET Core 2.1, and people will be super unhappy if they're forced to install .NET Core 2.1, and so we made that roll forward work as well. And I actually think I've heard 0 negative feedback on that choice now that I think about it. I think people think that's rational, and obviously I think we did good work to make sure that .NET Core 2.1 is pretty compatible with .NET Core 2.0 such that that's a reasonable choice. Now, this actually started with something Kathleen sent out, which was like, oh, how do you make .NET Core 2.x global tools work on .NET Core 3.0, which is an awesome question and an awesome scenario. And so the initial suggestion Kathleen made, which made a ton of sense given the mechanisms that we have in the product, is to multi-target your global tool. So that made sense. But then a couple of us, including me, said, I wonder if we need more mechanism in the product. Maybe we need at least some scenarios to roll forward across major versions. So that would be like a .NET Core 2.1 app or tool being allowed to run on .NET Core 3.0 by default in the case that the .NET Core 2.x isn't installed on the machine. So that's something we're looking at right now. We actually have not closed down that discussion. I think I'm on the hook actually to write up the design for that and post it on GitHub to get more feedback, but that's something we're actively discussing. I'd love feedback on that. So I think that's all I'm going to say for the moment.
Yeah, so the one question Kathleen asked is like, can you define what roll forward actually means?
Oh man, tough questions. So the basic idea is if you build an application for a given runtime, the best choice is to run it. So you built it, targeted it for the specific runtime, version 2.2.2. The best choice is to run it on that runtime because that's what the developer presumably tested with, and so that has the best chance of giving them the best experience. Now, roll forward means basically using a later runtime than what the developer intended. And so we kind of roll forward. I don't have a better word to say. We use this later runtime because we consider it to be compatible enough. Now, in the case of servicing releases, that we actually think the later servicing release is a better choice than what the developer intended because there's a bunch of security patches in there. The other ones that I mentioned, minor and major releases, rolling forward to those, are more based on the fact that the machine is not configured in the way that the developer intended, but we should make things as easy as possible for the users and not force them to install 200 different runtimes on their machines. You know, that's not a reasonable request on users. So we, roll forward just means use a later version than what the app did.
And let's clarify, Rich, that is when the version that's requested or a security version that's rolling forward doesn't exist on the machine. So if the right thing's on the machine, it runs. This is what happens when the .NET runtime doesn't find the right, it can't find what it wants.
Yeah, the only place where that's not true is in the case of security patches. We aggressively move forward to the latest, even if the one you asked or built against is on the machine. In the other cases, what you said is exactly true. We only roll forward in the case that you're missing the version that you asked for.
All right.
Do we have any plans to do this for major versions as well, Rich?
Well, that was what I was trying to discuss. Is we're thinking about rolling forward from 2.x to 3.0. We're thinking about it. We have not closed the decision there yet. Yes, we're actively thinking about it.
So what do you say?
If people want feedback, to give us feedback on that, the question is, if 2.2 does not exist on a machine that's in your production environment, would you rather see that system crash, or would you rather see that system try to run on the runtime of 3.0? That's really the question we're talking about.
Yeah, just to be clear though, it's not crashing. Crashing is a slightly different. It basically means it will refuse to run and it will give you an error message that specifically states why it didn't run. Crashing is a slightly different thing.
Right, you're right. Good point.
Yeah. Then the other thing is would you have a different choice for server applications like ASP.NET versus client applications like WPF and WinForms versus global tools? Because I actually think those are very different from one another, and people might have different viewpoints, and we'd love feedback across those. Or would you only accept one policy across everything, and that's the only rational viewpoint, which itself is irrational.
Yeah. So what are your thoughts on this? Because I mean, we have, I think I wrote a blog post a while ago. I think it might have been the Introduction.NET Core blog post where I talked a lot about our compatibility that we have with .NET Framework, where because we have roll forward on .NET Framework and because this is machine-wide install, we have this super high compat bar. So can you explain how, like naively, it sounds like we're going down the same path with .NET Core now, where we end up in the world where we can no longer evolve .NET Core like we do it today, because now everything rolls forward all the time, and now we have an incredibly high compat bar again.
Yeah, this is Emo saying he wants to make as many breaking changes as possible in the product. It's similar to .NET Framework, but different in very, very important key ways. So the problem with .NET Framework, especially in the 4.x series, which we've been in for almost 10 years, actually. Next year will be 10 years of the 4.x series, because I think we shipped that in 2010, right?
Yep, we did.
Some of us are starting to get a bit old.
Starting?
For some of the .NET releases, some of the children I have didn't exist yet. So anyway, yeah, so there's a super important key difference is you can't have, say, .NET Framework 4.0, 4.5, and 4.7.2 and 4.8 on the machine at the same time. So if you just have to make one choice, and so we really only had the roll forward choice was inherent in the deployment choice we made, and you just have to make one 4.x choice for the whole machine. There's just like literally no way around it. Whereas with this thing we're discussing with .NET Core, it's quite different, which is it's only in the case that the version you want isn't there, because you are fully capable of having multiple .NET Core major and minor versions on the box. In the case that let's go with the extreme example. Imagine we do roll forward, the app runs, and it does indeed crash, as Kathleen mentioned, because Emo removed an API, or the API changed in a really bad way, and so the app crashes. Then you have the opportunity to put, say, 2.2 on the machine, and then the app will run. So it's not this super systemic disaster type situation. The app might crash once, and then you have it's not even an escape valve. You have a formal opportunity to fix the situation. So I'm okay with that.
That makes sense. I mean, like that's generally what we tell our developers on the team as well. Just yesterday I had a conversation with Jared where he was asking what our breaking change policy is moving forward. So the one thing I would like to talk about for a brief moment, because that's I think also a topic that always causes some controversy when we talk about breaking changes. Like in principle, any change is breaking, right? That's why like people have this definition and say a breaking change is a change where an app used to work with the old version, it stops working with the new version. And while that's true in principle, that's not a very useful definition of a breaking change, because pretty much any change you can make to a product, making it faster, making it slower, adding new features can be breaking. You can always write code that used to work without this and stops working with it. So a good example here is we had an overload to a method that previously didn't have any overloads. And since the way you wrote your reflection code, you just look up a method by name, you ignore the arguments, and then suddenly your app stops working because you no longer find the corresponding match. And so we have defined on our team more like a document where we talk about what we decide is an acceptable breaking change. So if you go to CoreFX, there's an actual document, a markdown file that we try to keep up to date, that we talk about here are the kind of changes that we know are breaking and we do it anyway. So for example, adding new APIs can be a breaking change, and we said, sorry, like if we want to evolve the platform, we have to be able to add new APIs, right? And in the same way, we said like, performance improvements can be breaking. There's this, example that I think was around in the .NET 2.0 timeframe where we improved the speed of thread.start, where previously an app would start a thread and then immediately after calling thread.start, it would initialize data structures that would be that are basically read by the thread that just started. But .NET V1 was slow enough that by the time the thread actually ran, the data structures were already initialized. But now in 2.0, we made it faster. So we basically crashed the thread that just started because the data structures were not quite initialized yet. And so I think this code was actually in an Outlook add-in that almost all executives had installed that showed the picture of the person or something. And so we took Outlook down effectively with that change. And But this is a good example of something where it's like, well, performance fixes can totally break your application. And so this is another kind of class where we say, yep, in order for us to evolve the platform, we have to be able to make things faster as well, and developers have to absorb this. What I very often hear from people when we talk on Twitter or when we talk about why we didn't do certain changes is like, why don't you just do it? Like, it's all stupid people that write bad code. And it's not stupid people writing bad code. It's more like the assumptions you are making, right? The best thing a developer can do is write an app, test the app, and then deploy the app, right? Nobody is literally reviewing every single line of code and ask the question of like, can this possibly break, right? And the problem with .NET Framework is that we basically update the framework underneath your application, right? So you don't get to test again. The general idea with .NET Framework, with .NET Core is, well, there's a side-by-side release, so you have to do something to your application normally to upgrade to the new version. And roll forward changes this a bit, but the general expectation here is if this new version should break your existing applications, the fix is obviously just download the older version and install it side by side. And with .NET Framework, the real problem is you can't do that. And on top of that, you have the option to say, let's say you're a TurboTax or you're a Visual Studio where you effectively don't control the environment. You can always go self-contained and bring your own copy of the framework where you know exactly what it is that you're testing and what you're deploying. So that's I think the general direction that why I think we believe that we can be a bit more, I would say, optimistic with changes, right? We generally don't do breaking changes at a very large scale, like renaming namespaces or something we try to avoid, but we have not done certain performance improvements of .NET Framework because we know it will break the world if we do that. And so with Core, the hope is that we can get there eventually.
Right, Span's an example of that, right?
Yeah, Span is a very good example of that. And Span is also an example where, once you plumb it through the core stack, there's plenty of stuff where applications might fail now because we introduced new behavior that you can in principle observe. Even though we think it's generally a good idea, it doesn't mean that applications will absorb this without breakage.
Interestingly enough, from the F# perspective, there are some F# programmers who rely on type inference when calling .NET methods that have overloads, and that can work like usually the first time for like sort of a short-lived application if you call the right overload. But especially with Span, where Span overloads have kind of been added everywhere. Pretty much anywhere that takes a string now, there's like a read-only span of care or something. Mm-hmm. Well, that's actually a compiler ambiguity now, right? Because it's like, oh, well, you just defined this thing called X or S or whatever, but you didn't say what the type was, and you're calling it into an overloaded method. But it could work for either of these, and so the addition of those overloads can actually mean a breaking change for certain kinds of F# code. And so that's not to say that you're a bad F# programmer if you rely on type inference in that way, but that's just sort of like another way that sort of the notion of like, oh, just add an overload, that shouldn't like harm things. Well, that can in a way, and that's something that like we care about, but at the same time we can't like, stop adding overloads just because it could potentially break somebody.
Right. It adds to the complexity that there are different languages with different rules that are consuming .NET libraries. So.
Mm-hmm. Yeah, I mean, source breaking changes are like an interesting category in themselves because we usually think of source breaking changes as something that happens during development time, right? Where you did something to your project, you upgraded the target framework or something where we believe you are generally in the good position to make changes if necessary, right? We still don't want to make source breaking changes where your 3 million lines of code now generate 10,000 compiler errors because that would be pretty daunting. Yeah. But there are also cases where this can be runtime errors depending on what you do with .NET, right? There's plenty of people that write web services or other things where they had a run from source kind of story in production where the machine now gets upgraded and the source code gets compiled on the fly and now it stops working. And that's another area where we tried hard to make that better with .NET Core so you don't have those issues to that extent anymore. So I think there's one question that we got on Twitter that maybe Kathleen or Rick should answer is, does .NET Core have a tool like the Node Version Manager, NVM?
Okay, I'll take that, but unless Rich wants to. We don't.
How about you go first?
We think about it. We don't. We think about it. If there's not an issue, please make one because this is something that's out there, but we don't have that today. And we had the question around the SDK and the runtime, and I'm kind of taking that around the SDK and maybe Rich has a perspective on it that he wants to add either on the SDK or the runtime.
I do have a perspective on this question. I understand what the question is. We don't need this, is the short version. So the difference is, so we actually looked at MVM and related things when we built .NET Core initially. And so the huge difference is with Node, you always have one version of Node on the path. And so what MVM allows you to do is very easily switch which one of them is on the path and which one you're targeting, but you're fundamentally only ever using one. And then the project is subservient to that choice. For .NET Core, we went a different direction, which is we inverted that, which is all SDK and runtime versions are always available. Well, not really SDK. Let's ignore that for a moment. All runtime versions are always available, and each project gets to make a different choice, and then the SDK honors that. So there's kind of no need for a version manager in that sense. Now, the place where we do have more of a problem, and we kind of get closer to the MVM thing, is we have this global.json file. That is, in effect, our MVM. We are not actually super happy with that. We've talked about it, I think, 6 million times. I would personally like something that was, different. I'm not going to go into all the options, but I think global.json is not good enough. But we only need it, the key piece is we only need it for SDK selection. We don't need it for runtime selection. NVM is, at least I think, it is closer to the runtime selection thing that we already have solved. So that's my answer.
So what does everybody here think of the now defunct DNVM that existed with DNX?
Yeah, I was thinking about that.
It makes it more of a real-time situation instead of here's my project, this project expects this SDK in order to do its thing, and that's why the global.json actually dropping into a project or into a solution. But there are problems, including the fact that if you put it in the project instead of the solution, you can run into problems if different projects have different SDKs and they're trying to build together. So we have a long list of things about global.json that we are aware of. The problem is that we can either tweak it or we can wait until we can make a well thought through change to it. And we will tweak it where we need to, but it's a little further out to do that well thought out, deep thinking on the set of problems, because there's other configuration problems, and there's the fact that we don't recognize what's basically the repo level or your world for this project. We recognize individual projects at the CLI level, and so there's a whole set of interlocking problems that we look at when we think about the global.json problem. And generally, we just so far have said we have more important things to spend that much time on, and we'll tweak it, and we have tweaked it. We have the custom SDKs in it. Going forward, I think you will eventually see big changes, but not in 3.0.
I just want to register what my number one scenario is that causes me grief on this, which is I installed .NET Core 3.0 preview, or really any kind of preview on the machine. It then takes over my whole machine. I'd love it to be the case that there was a setting, and I've written this up on GitHub, where I could say, by default, please use the latest stable SDK machine, and then let me opt in either per project with global.json or with some other mechanism that is more DNVM-like to opt into using 3.0 preview CLI. And the thing about that bothers me the most isn't the fact that I'm using the 3.0 CLI, the 3.0 preview one. It's that when I type .NET new, it creates 3.0 projects by default, when for a lot of the time I actually want 2.2, like I'm talking about today, I want 2.2 RTM projects. And I'd even be happy if I could just type -F for framework, netcore app 2.2. That would satisfy my needs. I've asked for this, but it hasn't been delivered. I'd be I'd be curious if folks on the call have this same level of kind of unhappiness with this very specific user experience.
Are you asking for a mob with pitchforks so you can get your idea implemented?
Exactly.
I like the NVM with the
interlocking problems on this. One of those interlocking problems is the relationship between templates and the SDK, and so there's a whole bunch of problems that just wind up woven together on this one. And I would love to break that where that wasn't a problem. When I say tweaks, we might do a tweak around previews for 3.0. It's not in yet, but that has not been completely removed from the table. It's only been removed that will actually, quote, fix global.json, because we're not quite sure what fix means just yet. So we may tweak it, though, to better support previews. We know that's one of the big pain points.
Cool. So I would suggest we move a little bit off of runtime and tooling. There's only a few questions that I think would be good if Kathleen or Rich could quickly answer this. So are there any plans to have Azure DevOps agents with VS 2019 previews available so we can build our experimental .NET Core 3.0 projects? Anybody know?
I don't know.
I'm going to have to give that to Rich.
I know that we've discussed it. I actually don't know what the answer is, but I know that it's come up several times in the recent time frame, so we need to provide an answer on it. So I agree with the scenario.
Like we don't have to wait for build agent. Wasn't the idea that we can eventually also provide a way to you can just acquire random SDKs during the build?
Yeah, but I don't think we've written up good documentation. It's something that deserves a blog post.
Right. And then there's one question: how stable is it or will be IL-link.tasks, link optimizations of output binaries? There are, of course, other tools like that. Do you invest time on this or someone recommends it? What will the future hold? I think Richie worked on this quite a bit, right?
It's intended to be, it's kind of been a bit experimental-ish up to this point. The idea is with 3.0 that it is fully supported and works awesome, blah, blah, blah.
Although, let's throw in there that that's actually not, we still have work to do. That's not really a Preview 2 feature. That's something you can look forward to as we get closer to RTM. We're very excited to get linking out there because we do think that the self-contained application scenario is a good one, and the linker really helps that scenario not be insanely large. So we're super excited about getting that out, but it's not quite there for Preview 2. It's pretty much where it was before for Preview 2, which is it's available on, is it MyGet or NuGet, Rich, where the linker is available?
I believe it's still on MyGet.
Okay. There is a preview linker. If anyone wants to try it, they can let us know, and we will track that down. I don't think any of us have that link at our fingertips.
Cool. So then let's shift the focus a little bit towards languages. So there was one question. It was for F#, but I think the same can be answered for C#. Is what are the timelines for F# 4.6, and what are you most excited about? So first question is like, how does .NET Core 3.0 and language versions, how does that work? Like, what do you guys ship with, and like, how should people think about that?
Well, I think that was well, so that may have actually been a different question because F# 4.6 is going to come before .NET Core 3.0.
Oh, exciting!
But we can certainly talk about both. F# 4.6 is scheduled to go out in release form with VS 2019 and the corresponding .NET Core SDK updates. Both are in preview, and we're very close to having a preview available for people, both a preview of VS 2019 and a preview of an SDK that both contain the compiler that has the F# 4.6 language implemented and the F#.core 4.6 NuGet package that it depends on. And the feature that I'm most excited about that is anonymous records, which are sort of a slight variance on the existing record type, except they're anonymous. And the compiler internals, it actually just computes a SHA-1 hash and says that's the name. But there's a few benefits that you get from not having a name and a few things that are not quite as good. It's sort of a different trade-off. But it makes things a lot easier whenever you interact with certain components like ORMs that kind of always assume you have an anonymous type. And those things are really annoying to use in F# sometimes, but with anonymous records, it's significantly easier. They're really nice for, like, say in your organization you have a bunch of microservices that just serialize and deserialize like a very small amount of data, and that, like, they're just responsible for just like a tiny amount of information and sending that tiny amount of information. You have another microservice that's only responsible for reading that tiny amount of information and doing something with it. It's kind of annoying to have to like model your data types for like, you know, maybe 5 or 6 fields that are just in this single container, and you can just do that all in line with anonymous records. It makes it very very succinct. And you don't need to have like a project-to-project reference between the two to see it. Like if you say you're deserializing something into this form that you have specified, kind of just the way the serialization works, it just plain works. So it's really good for that scenario, and then also for working with data, it's very nice because the copy and update syntax, or withers as they are called in various designs that are happening around C# for the idea of records. With anonymous ones, you can take an existing record and you can actually put more data into it. So say you have your own record definition that contains an X, a Y, and a Z field. You can say, oh, I want to create a new anonymous record that is an instance of this record, but with a W field added to it. And that W field could be something completely different. So that's really helpful for, like, you know, you're working with data that's sort of just in this compact record-like format and you want to transform it, but you don't want to model all the types needed for those transformations because the transformations are kind of more of a means to an end. And they're really, really nice for that, and you can actually do some pretty clever stuff with them. So yeah, so there should be a preview of that out very soon, and there should be a release of that out later when VS 2019 ships, and when the corresponding .NET Core SDK that will go into that ships in release form too.
So how does F# versions map to releases? Like, do you just ship it whenever you feel like it, or is there like a major timeline that you snap to?
It's yes and no. To a question that was not a yes or no answer. Sorry, not a yes or no question. So we take this approach of like when things are ready, like from the design feels baked, and we feel as though it has been enough time, and you know the compiler is in a good enough state to rev a major language version. Then we will take a look at what we have and see if it makes sense to ship something. If there's a compelling thing that we have, like in the case of anonymous records, that's actually the only language feature going into F# 4.6. And it's not this revolutionary thing or anything like that, but it has a lot of little use cases that just people have mentioned over time, and there's a compelling enough story for us to be able to say, oh, well, there's this new set of kind of smaller capabilities that you can do now. And that's sort of where we are. Now, that's sort of like on a short-term basis. Like we did a similar thing with F# 4.5 where we were in a good enough state to say, oh, we can have full span support, full biref-like struct support, and things like that. And once the design was baked and the compiler implementation was stable enough, we said, okay, what release can this fit into? And we sort of went from there. However, there is much more of a long-term thing going on with F# 5.0 because we want to also do nullability for reference types that aligns with the nullability work going on in C#. And that is, you know, all aligned with .NET Core 3. And so we're trying to position everything that could fit into that bucket much more in advance. So and it's not just going to be nullability, but that is sort of like the impetus behind an F# 5.0, because it's that feature in particular is, I personally think is going to be one of the most transformational things for .NET in the long term. We're just going to change the game about reference types. Like people will just not worry about nulls like 90% of the time anymore after they've like many years have gone by and libraries have updated, various parts of the BCL have updated in some form or another, and you just work with data that you know is not going to be null, and you just don't have to even worry about null checks anymore. That's sort of a reality that a lot of F# programmers have today when they work with F# only types, which are almost always non-null by default. That's sort of the world that we're trying to get to. And so because that's such a big shift, I think it warrants a big major version change. Yeah, that's sort of how that all is. However, we're not shipping a preview of that in the upcoming Visual Studio because it's just not at a state where we could really say that it's usable by people. So
not quite ready yet.
We're not going to ship a totally broken preview compiler in Visual Studio side by side and then say, yeah, try it out. It's all a work in progress.
Seed crushing on your box.
Yeah, unlike on the C# side where things are more stable in terms of what could be. I mean, like, that isn't to say that things won't change for C# 8 and like, with nullability and things like that, but it is to a point where we say, oh, we want people to really try to bang on this feature and give us feedback right now. So I think that's an important distinguishing point between the two right now.
Yeah, that's a good segue to C# actually, because we don't have a version of C# that comes out with VS 2019. Right? We decided that the next major version of C#, C# 8, aligns with when .NET Core 3.0 comes out. And part of that is that it has a lot of dependencies on the runtime, both the library dependencies that, every version of C# comes with some new library that it expects tuples dependent on new types and so on. And we have some of those as well, but also actually this time around we're building a feature that depends on new actual runtime semantics. Like we're actually evolving what you can say in IL for the purposes of this feature, which is an exciting new old thing that we're coming back to. We haven't really we've done sort of little bits of it, but not in a big way since generics.
Right.
And I can't remember when we shipped that, in 2005. So
I was in high school.
we, in various ways, again, due to some of these limitations with .NET Framework and the classic .NET Runtime, we haven't been able to evolve the semantics of the underlying VM, the runtime itself, for a long time. So this is sort of our first step in that direction. It's really exciting, and I hope that it doesn't crash and burn, because I really want to do more of it after, and I don't want that house to burn down. But so for those reasons, we decided, okay, C# 8 aligns with .NET Core 3.0, which is sometime after VS 2019. So we are now in this delicate dance where we are shipping previews of C# 8 in the previews for VS 2019, even though it's not going to RTM in VS 2019. In fact, we're going to keep shipping previews of C# 8 in previews of subsequent minor versions of VS until we get to the one where .NET Core 3.0 aligns with, and we'll actually have an RTM of C# 8. So it's a little bit of a dance. We depend on both previews of .NET Core and also previews of VS, where we ship the actual compiler and IDE experience previews, and we've already messed up several little things where they didn't line up because they don't even ship on the same dates necessarily, and they're not entirely coordinated. So there are little things where, whoops, the compiler targeted a type that had this shape, but we changed the shape in the, we've had a few of those.
Oh yeah.
So that's all fun and games, but
I think that's generally like a feedback that I've heard, is that .NET has an influx of version numbers and product names. So I think that's partially like naming is hard and versioning is even harder. I remember when Kathleen joined the team and she said, I want to fix versioning, and I just laughed and said, like, that's impossible given how we ship here. But I think the question in general is like, why is that? And I think part of the problem that we have that other people don't have is that, when we talk about DevOps all the time, where you basically can just, when things are ready, you ship them, and not ready, you don't ship them. When you have a service, when you control the deployment environment, it's much easier to do these kind of things where you can roll out things for a small set of users. Like in Facebook, they can just say, we have a certain panel that shows up for certain users. But I think for software that you install on your device, that you depend on, that you declare dependencies on, you need some way to identify what it is that you're depending on, right? And version numbers and product names are the best mechanism that we have for that.
Right.
And that means, well, we have to decide which vehicle things go in, and it is, as you said, it's an ongoing challenge to find what is the right vehicle for a given feature. And what people often also don't understand, I think, is, or not fully, I think, grasp from a language standpoint, is that it's not just the language, right? Very often you want IDE features that correspond to the language features. So in Tuple, you want, for example, an IDE feature that can tell you that you're missing the tuple type and you should add a reference to that, or you have maybe tooling like actual menu items or commands in VS that go with that. And the same way, you need like a framework update to have those types, right? And I think getting all these things aligned on a schedule is the thing that's
shipping the languages is really like turning the crank on everything in the tool stack at the same time.
Well, you could imagine. I mean, you could imagine all sorts of little tooling features just for the nullability feature. Like, I mean, there's. Yeah, so like that isn't to say that all of these are happening, for example, but I could imagine somebody saying, oh, well, I don't want to hear about warnings from this thing. I want some sort of context menu for whatever this thing is, some node in the IDE where I could right click and say, just turn it off. Or have something where I could say like, oh, I'm pointing to this thing, I want to ignore what's coming from there. And so that's one of those things that's interesting to think about from a tooling standpoint and incredibly difficult to get right, which is why a million little tooling features end up not all being created. But but like that's it's challenging, right? Because I mean you can't just you can't create it all in one go and get it all on the same date and get it all right at the same time. And so that's why this whole notion of shipping a C# 8.0 preview, alongside Visual Studio, even though that C# 8.0 is not going to RTM for that given version, matters because that allows us to try things and get feedback on it rather than think we got it right and then ship it, and then have customers tell us, oh, yeah, no, that wasn't quite right, and then we go, ah, oh, darn it. Well,
it's and the nullability feature is really nullable reference types is really proven to be a different language feature in so many ways than any we have ever done before. Like, first of all, we talked about breaking changes before. This is a language feature that's designed to break your code, right? The whole point of this language feature is to warn you about things we didn't warn you about before, so you can feel more confident that you don't have these nulls that blow up in somebody else's face 3 years later when they call your code.
Right.
And so so we've spent all these years being very careful not to blow anything up and to tread very lightly with new features so we don't mess existing features up. And here's one with sole purpose is to do that. Okay? So the whole game changes, right? Now we need to think about how do you opt in. There's a whole experience outside of the language feature of how do you use it, how do you activate it, and a lot of the way, like the primary way you'll interact with it is that you'll get warnings and you'll fix your code, right? And it's not primarily like a new expressiveness that will generate new behaviors,
right?
And it's not a shorthand for anything. It doesn't actually make your code shorter, right? It makes it a little longer because you add question marks here and there, and then you add these extra null checks and things that you forgot about that it'll tell you about. So it's very, very different, and it's been extremely and much more interwoven with other parts of the tool stack than we used to. It's extremely fun and gratifying to work on because it's just so different.
I just get a kick out of the idea of designing a syntax that we intentionally want people not to use as much as possible.
What do you mean?
Well, you have all those question marks everywhere, and then if you get those mixed in with generics, then all of a sudden it can get, and then so you look at this sort of all these crazy question marks, and then that forces you to think, whoa, well, if I have control over what all these types are, maybe I should consider making them non-nullable just so that my syntax could get nicer.
Sure. Well, I think question marks, it's one more character, okay? Yeah. In a generic type, you might add that character multiple times. I think, but that actually goes to part of the motivation for the syntax, which is that the nullable type should be a little harder to write than the non-nullable. The default should be non-nullable because then you only ask for nullability when you need it. Okay, I actually need this type. You don't just fall into it, and now everybody else has to check around you or be, program defensively against you. You opt into, okay, null is meaningful here, so I'm going to embrace it, but now everyone who's consuming it can see that I'm doing that. The compiler is going to make them heed that and be careful around it. So, yeah.
So I want to throw in an update for VB in here too, so people know that it's out there. It's going to be in .NET Core 3, and its numbers happen to correspond to Visual Studio 16, which for the next 6 months will be unfortunate. So Visual Basic 16 will not ship in Visual Studio 16.0. It will ship with .NET Core 3 in the version of Visual Studio that C# 8 ships in. So 16.2, whatever, whenever it comes, it will ship with .NET Core 3. And the major feature for VB of .NET Core 3 is that it runs. It doesn't work very well on 2.2, and we're fixing that. So the Visual Basic runtime will be there in .NET Core 3, and Visual Basic should run well on .NET Core. So very excited about that. Visual Basic .NET is moving forward. In 16.1 and 16.2, we have things on the table, both for some features that allow us to stay up with interop with C#. There's something called default interface methods that may happen. If that happens in C#, we need to incorporate that in VB. And also, we've got some VB.NET specific features that will be things like pattern matching in a very VB.NET way. So there's more on the table for 16.1 and 16.2 of Visual Basic.NET, which will not be coinciding with those Visual Studio numbers. They'll be offset for a while until we get the next round going. So Visual Basic.NET's definitely moving forward, and that's some of what you can look for in the next 6 months to a year.
We're all quite excited to see VB killing it on the TOB index. It's been crawling up and actually surpassing C# the last couple of months. So there's a lot of VB activity out there.
Interesting. I didn't hear about that. So.
Yeah,
I think it coincides with Kathleen having joined the team. I'm quite certain there's a connection.
Oh, here we go.
Yeah, Mates people ask lots of questions about VB.NET now that I'm running this part of things. So no, it has nothing to do with that. But the TOB index is one interesting measure. People are definitely active in VB.NET. We have other measures that definitely people are doing it. They're a portion of our customer base that we care about, and we'll keep doing the right thing for VB.NET, which is not going to be the same thing as C# going forward. And we've got a strategy announcement on that. People can reach out to me. They can also go to VB Lang, because we actually have an active dialogue with the community on design. Design is very slow paced, and I think sometimes people miss just how slow the pace of change comes in design. But we definitely have those conversations going on, and that's at github.net VB Lang.
Actually, let's do one thing really quick, because I think that's something that most people are not aware of, is that we have a bunch of GitHub repositories that are not where necessarily code lives. So you just mentioned VB Lang. That's a repo where the language is being discussed, and like I have something open here from C# Lang, which also exists, where it's a proposal for the range feature, where Matt talks about what the syntax will be and a bunch of other stuff, and that's basically how you can track what's going on without actually reading the source code. And we have another repo here called Designs, where I have a spec that talks a little bit more about how index and range work in the base class library. So if you want to engage with us on design questions, slightly higher level ones, I think those repos in particular are very interesting, because they allow you to talk about cross-cutting features where you don't necessarily have to worry about which repo things are living in, and you can actually talk a little bit more meaningfully, I guess.
Right. I mean, we realized at some point a couple of years ago, I guess, that being open source is great in sharing the source code for the product and working on that together across community and Microsoft. But then it turns out that there are many more artifacts and many more things that are produced during the development of .NET and the languages that aren't code, and that don't share well inside of a code-oriented repository. And so we, specifically for the languages, we made these C# Lang and VB Lang repos as the place where we keep all those artifacts that are part of the, I mean, it's not like a publishing venue, it is a repo. This is where the work happens. This is where the design notes and the specs and everything live, right? So that has been super great for making it language evolution a community activity.
I agree. In general, I think written text is so much more powerful than basically anything else that you can do with normal PRs when you talk about code, right? Because the thing is, if you have 2 paragraphs in a document, it's so much easier to change the wording or change it slightly early, rather than changing, large swoops of code later on. And the nice thing with GitHub is that documents don't have to be different from code. You can still talk about pull requests on documents. You can still engage on design questions at a fairly high level without necessarily talking about code. And having them in dedicated repos is actually helpful because it removes the noise a little bit, right? It wasn't as ginormously large as a repository, right? And the language design nodes and the suggestions would just basically be dwarfed by all the small bug fixes and test breaks and all the other stuff that you have to do day to day. So yeah, I encourage everybody to check that out. So the one thing that we have kept for our end, so John is already getting psyched up, I hope, is we have a small thing that Kathleen Schlotzer will talk about, which is a community-driven project that Kathleen started to party on. I would just pitch it as it's something that everybody has ever written, probably at least 4 times over at this point, and we have received lots of feedback over the years to add something like that to the framework itself. And Kathleen, do you want to talk about what that thing is?
I'm going to keep this super short because I want to give it to John as quickly as possible. To start out with, don't give me a lot of credit. The team has been fantastic. We saw a problem. We pulled together a community and Microsoft joint team. This is a side project for every single person involved. We're doing this because we passionately feel like it's an important problem to solve, and we think we have the traction to do it. And with that, I'm going to have John talk about system.command line and what it does. And you'll have to tell us, Imo, how much time he's got, because we're coming up on the hour. Can we run over?
Yeah, we can totally run over. Like last time, they went over by 20 minutes. So we should feel free to run over a few minutes.
Fantastic, because I'd really like folks to be able to see what's going on with this project.
All right, John, take it away.
Sure. So this project started out, it kind of had its roots in the .NET CLI, and there are of course a lot of command line parsers out there in the .NET world as well as in other ecosystems. So it becomes kind of a joke, oh, you're writing another command line parser. Why are you doing that? And the thing that we saw, as we had, there's a few different ones that Microsoft has published over the years. And they all have kind of similar capabilities, and they kind of deal with the parser layer, and they provide some API over a parser layer, and they have a few opinions. And what you find is that as you look around in the ecosystem, lots of people have opinions about API, and then they couple the implementation of how the syntax of their command line is going to be parsed and how that's going to be bound into arguments gets coupled together. And so I could choose, if I want this particular syntax that this library provides, then I end up having to take the opinions that it also comes with regard to syntax, and then that may have implications for the way that I structure my application. And each reattempt of a command line parser has kind of stopped at that level and not gone down to some more things that might be considered the harder problems, maybe, or the problems that people actually don't, people don't actually want to write a parser, right? They want an application framework. They want a way to handle arguments. And so over and over, people reinvent the same pieces. And we said, well, in the CLI, we had a couple of problems that we wanted to solve. One of them was around testability. Invocation was invariably coupled to the way that we were parsing. And there wasn't an abstraction that allowed you to say, just what is my parse result? It's just an AST, basically, for your parse result that lets you then potentially test and make sure that your parser still works the way you expected before you even get down into the invocation layer. And then invocation as well, we said, well, once we have that AST, we can do some kind of fun stuff. Once we get down into the lower layers, there was infrastructure there that ideally would allow interop between parsers, right? So even if you have different parsers with different API opinions, they might be able to share implementations of specific things. How do I provide help? How do I format help? How do I provide a version? These are things like you kind of want all applications to have similar look and feel. And I feel like one of the things that we recognized was that the end users of command line applications end up in this very fragmented user experience because all of these libraries are doing different things. So I don't know what is the correct syntax for an option. Is it a dash, a double dash, a /, and then with .NET Core as well, you have a larger integration, I think, of Windows and Linux and Mac users all using the same applications, right? So you kind of want to unify this field a little bit. So I'll show a couple things here. What I have up here is the way that the entry point for a console application has looked forever in .NET. And you get some string args, right? And one of the things that we thought about was, typically I would have to go and parse these args. I might look into them positionally, naively, say, oh, someone asked for help. I'm going to check they asked for help, and I'm going to return early. Write something out to the console. We said, well, that kind of control flow is kind of annoying to have to write over and over again. So we wanted an invocation pipeline as well. And then we thought, at the end of the day, what I really want is strong typed arguments. What is the simplest thing we can do? Now, what this led us to is this. It's an experiment that we call dragon fruit. This is a strongly typed entry point, and what this does is it effectively configures a parser for you based on the types that you'll see there, and then gives them back to you. It provides help and based on the XML comments, and it provides default values based on just sort of idiomatic C#. Now I'll show another app. Later I'll get maybe a little bit more into what the underlying syntax is. This is an application layer that has sort of a specific API opinion that sits on top of this core that we're saying should be kind of fungible across different app models. I want to show a couple of the things that we can do here, because what you'll notice is that in this application, there isn't. I'm actually demoing something slightly different here, but I want to show. This rendering playground is an application that uses the dragon fruit model, so it also has a strongly typed entry point. And I'm just going to show what help looks like first. So this is help for this application. I'll get into a little bit of what the rendering is doing, but you'll see that this is the entry point for the program. So it has the same XML for help output and a bunch of strongly typed arguments with defaults. Okay, so there's no early return here for help. We short circuit on help before invoking this method. So another thing that we can do with this.
That means the user doesn't have to write their code, or?
So the user doesn't have to write any code to deal with help at all, right? What they write is they just write the signature for their entry point. Now this is not the only way to write an application on top of system command line. This is the dragon fruit layer that goes under and it configures your parser for you, and it configures your invocation pipeline for you. And it comes with a bunch of freebies, and help is one of them. Another one is the ability to understand your parse operation. So we have this concept that we added in as well. And this was to try to provide certain functionality that would cut across any application that uses system command line. So if I parse, for example, something like this, I can get a description of the parse tree back, right? And what this is showing me, that the bang is showing me that sample was invalid, right? If I run this without parse, and these are other things you'll get. You'll get things like this. If I say I have I have an argument missing, or if I try to parse something to the wrong type, things like this, I get error messages for free that kind of describe what I did wrong. We support custom binding to different types, directory info, and file info are provided for you, and things like fairly sensible. We also have support, again, these are things that we can do with the abstract syntax tree that's based on the parser, is that we can do completions. So right now I'm tabbing through, and you can see the help there, I'm tabbing through the different options. Anybody who uses system command line gets free support for completions, and this works in a way that works in cross-platform. Typically, you would need to write a shell script that understands the semantics of your specific application. So PoshGit or BashGit provide completions for Git. Right. Here, what we're saying is that your application itself, written in .NET or in C#, is the canonical source of information, and these are extensible as well. Some people might have seen an experiment that we did with the .NET CLI that allowed you to tab through NuGet packages. So you can provide your own completion providers, and it works cross-platform. There's another thing in here. We have debugging support, and these things are all. What I'm showing here with these square brackets is a syntax convention that we kind of created to use Rich's term. It's a bit experimental-ish, but what this is doing is it's allowing me to intercept the inputs to the application during parsing, and then effectively I can change the parser result before it passes into the invocation pipeline, and I can do all kinds of things with that. The suggestions are actually driven by one of these, as well as a global tool called .NET Suggest. We provide one shim script, and then anything that's using system command line redirects through that .NET Suggest global tool into your application itself. But you can call your application directly, and you can see, what are the valid completions for this, and it is contextual. I don't have an example right here that has subcommands, but it's context sensitive. Another thing that you'll see, and I can give a quick demo of that. Actually, we do support sensible completions for things like for things like enums. So here's an enum. Okay, I'm just going to rebuild this really quickly. I'll get back to the rendering thing. There's a reason why I took the enum out. But just to show that how this works, if I say .NET suggest, one of the things that's interesting to note here, we'll come back to that. We do substring matching. This is intended to kind of, there's output mode. Right, so the types of the enum are returned here. If we find a bool, it'll complete to true and false, but since it's a bool, it's a flag, so you don't actually have to specify an argument, things like that. So those are some of the high-level features of it. We just got a PR for suggesting typo corrections, which is really nice, and it builds on top of this same invocation pipeline. And then the other thing that we're trying to tackle, again, thinking about problems that are sort of new cross-platform problems, some of which are old cross-platform problems, is rendering is actually kind of an interesting thing. In the I think the Windows 10 anniversary update, they introduced support for VT100 codes to be correctly interpreted by the terminal, and this applies to all Windows console applications retroactively. So in Windows 10 and higher, you can using Win32 API, you can elevate the console into a state where VT100 codes are interpreted as colors and cursor movements and things. And this is this in-process signaling is actually really nice for cross-machine communication, because everything is part of the string that you're sending to standard out, standard error, or whatever.
So it's one of the reasons when you invoke Git, and Git by default like pipes to less, right? So when you say git log and the screen exceeds, then it doesn't just flush it all out. It just gives you like the less feature where you can scroll up, scroll down, but it preserves the colors, right?
Yeah. Yep.
And that's because the output contains the information, I suppose, right?
Yep. Yeah. Whereas with the system.console APIs, this is all done by effectively side effects, right? Where there's methods being called on system.console that set the color and things like this. And this is kind of hard to manage, hard to test. So we also wanted to introduce some abstractions to make that easier, right? And especially for, if your process calls another process and redirects output, and that other process emitted VT100, then suddenly you've got all this goop in your console output, and you don't really understand how to read it. It wasn't what you wanted to look at. So again, with these are things that are potentially cross-cutting, and someone doesn't want to have to write the code for this. You kind of want to handle it at the library level, ideally, and then everyone can take advantage of it. So what this is right here, there's a bunch of different samples in here that you can play with. This output's kind of, it's not totally obvious that this is VT100 enabled terminal, but things that you can note here that the Windows console doesn't normally let you do is that kind of hot pink color and the underlines. Okay, so this is just a little implementation of dir that I wrote just to kind of demonstrate this. Now, there's another thing that we can do, and I'm gonna run the same command, but I'm gonna use one of these little directives, and I'm gonna set the output mode to, I'm gonna tell it not to enable VT. Okay, I think that writes. Okay, so this is what you would get. This is the same output with system.console, or so if you were to run this program, and we're detecting this on the fly by default. So what the directive is doing is letting you override the behavior, but we're detecting it on the fly so that when things like this happen, right? Now, obviously, setting colors, if I'm going to redirect the output. Right.
You don't want garbage in your output file.
Right, exactly. Now the default behavior that you saw before was that when I ran this was that I got a bunch of VT100 codes. Right. But the output here is still correctly formatted. And so to see what that would have looked like, I can also tell it. I can redirect the output, but with the output to see. And then here's the VT100 code. And that can be useful because you might want to tell another application, hey, I'm in a context where I'm willing to accept VT100. Right. Tell that other application, give me back VT100. So it provides this kind of interop.
Like less would be an example of that, where you pipe the output to less to actually get that experience. But this is super cool. So how can people play with that? Like, how do they get access to that? This has been in the works as a side project now for about a year. And we had
external contributors that we invited because they were interested, and we started pulling people in gradually and kind of moving the design in the right direction. And it's open now, so it's .NET/command-line-API. There's a few different things in here. There's the system command line library, which is currently, it's not on NuGet.org yet. We're still in the process of setting up package signing. The binaries are signed. It is on MyGet, and we can share a link to the MyGet. And there is a link here on the GitHub page to MyGet to get the latest packages. There's also the .NET Suggest tool is there. The .NET Suggest tool is published on NuGet.org right now. And then there's also system command line rendering, which is a little bit more immature at this stage. We'd love feedback on any and all of these things. And anyone who wants to get involved and thinks this is an interesting project, we would love feedback and help.
Yeah, let us know in your comments what you think. Like, hopefully you find it interesting, and then maybe we should cover it a little bit more in detail. Maybe a blog post, maybe some videos to actually get some more people excited about it. I'm personally super excited about it because I wrote at least 2 command line parsers, I think, and my team has, I think, at least 3 or 4 copies floating around of command line parsers, and so it's cool that we can finally get to the point where main doesn't give you just a string array with args, but you can actually do something meaningful with that. So you can actually focus on the application rather than parsing individual characters out of a string and then messing up the quotes and all the other things that you have to get right.
Yeah.
That is super awesome. So then I would say we wrap it up for today. Like hopefully I think we are on in 4 weeks from now, I believe, if the schedule, if I have the schedule in my head. So we will have one community stand up every week, but different teams rotate. So we are basically due in a month from now again. The general flow will be moving forward also that we will involve a little bit more from the community side, where we actually showcase interesting pull requests, interesting community projects that are worthwhile highlighting, to give a little bit of the love back from the team, to actually let you guys know that we are actually seeing what's happening. And since the holidays happened and I'm generally not very organized, I didn't prepare this for today, but the general idea is that we will have that readily available and we can share it off the screen. So then I say thank you very much for all the people that are here in the room, and also all the people that are that were joining us live and asked a bunch of interesting questions. Keep it coming, and so God will, we will do many more of the community stand-ups. All right, thank you guys.
Thank you.